All right, so in our last section, we talked about what a matrix is and then how to combine matrices via both addition and multiplication by a constant, so a fixed number that multiplied each entry in a matrix. So in this next section, we want to talk about combining matrices via multiplication, i.e. multiplying a matrix by another matrix. Now, the rules here are a little specific, sort of like we saw with matrix addition, where it turns out, unlike numbers, we cannot always just add together any pair of matrices that are given to us. By the same token, we can't always multiply a pair of matrices together. The problem is, the rules for when you can multiply two matrices together are a little bit more complicated than what we saw in the just check to see if they're in the same size case of talking about addition. So the notes file in Moodle, which again, I take for granted you've got open while we're looking at this, specifies, like a paragraph of text describing how this ends up working out. In my experience, I found students may find it more useful to look at this sort of visually. So imagine we were multiplying together a pair of matrices, A and B. And so we know the sizes of each of these guys. So A needs to be, we say A is m by n. The dimensions of B are not exactly the same as A. There are some cases where that is true, but it's not always the case. So the way the text describes it, it says the size of B is n by p. I like displaying it like this because it gives us sort of a framework for how to arrange these guys. Because the idea here is these two values on the inside, these n values, they have to match. M and P can be radically different from each other, or from N. There doesn't need to be any connection there at all, so long as the two values in the middle end up agreeing. And what ends up happening that determines the size of the product matrix when we multiply A and B together to give us some other matrix C, the idea here is that we sort of like lift these values out, and then the M and the P kind of end up squishing down to give us the size of the new matrix. So this guy is M by P. So you might imagine sort of like a crane kind of pulling this block out, and then a couple of machines pushing them together to give you the size of the new matrix. So that's particularly pretty handy when it comes to describing one of these things. So looking through the examples here, we give you in the notes file 3 different matrices, A, B, and I. I assume that you've got that you have the file open while we're looking at this, so I'm not going to spell out the matrices and use a whole bunch of board space and ink and stuff. You've got them there, let's just use them. Okay, so the first product that gets listed for us to calculate here, it says is B times A, given those example matrices. All right, so hopefully you can look at the matrices and determine the sizes that go into this. So looking at B, it's got 4 horizontal rows and 3 vertical columns. So that's a 4 by 3 matrix. A is a square matrix with 3 rows and 3 columns. So, all right, so that is how these things line up. And as you notice, those two do, in fact, agree with each other. Both of the inner values are a 3. So we could do this product. We can do that. And then when we take those guys out, squeeze the other 2 pieces together, the product matrix itself will end up being 4 by 3. All right, so running along the same lines, right underneath that, this is one of those things that you're sort of used to dealing with when it comes to numbers. Multiplying numbers, the order doesn't matter, right? 5 times 7, 7 times 5, potato, potato, they both give you 35, right? Let's see if that happens here. We flip these around, so instead let's try to do A times B. Well, like we said, we've got to check to make sure the sizes line up. They don't have to be exactly equal, but they do have to, have that, component in the middle in agreement. So we have 3 by 3, 4 by 3. Box in those middle guys, and you should not need me to tell you that 3 is not equal to 4. If you didn't know that coming into Math of Finance, we should probably talk. Anyway, so those don't match up the way we need them to. As such, this product is undefined. So sort of like we said that we don't try to define the addition of two matrices that aren't the same size. If the dimensions don't match accordingly, the product is just undefined. I prefer that over saying that it does not exist or, not applicable as something students have written sometimes. So that's that. So not all matrices can be multiplied together, and the order in which you do these really does make a difference. So even in situations where you have two matrices that you can actually do the multiplication just in terms of sheer, the values, as it turns out, you're still not guaranteed that A times B and B times A would in fact end up giving you the same thing. So you do need to be careful with that. All right, now you may be wondering, great, so now we know what types of multiplication we can do. So how do we actually do it? Again, the notes file has that formula up at the top. You can use that. You may find that useful. Again, kind of like this description right here. I found students generally work a little better with it, sort of if it's presented in a visual context. So I'm actually going to skip over the calculations that follow in the next few examples. So I'm actually jumping to example 2 on the second page of the notes, where we're given some variables in a matrix equation, and we're asked to see if the equation holds up for certain values of the variables x, y, and z. All right, so what in this particular example ends up determining what we do is we take the matrix that's listed here, 1, 2, 1, 3, 4, -2. And then at the bottom, we've got 2, 0, -1. And those aren't spaced quite as much as I'd like, but I think you can tell what's going on. So I'm going to feed in those x, y, and z values that are given to us. X is 2, y is -1, z is also 2. 2, -1, 2. And the idea is we want to see if this matrix product in fact matches the right-hand side that's presented over there. So for what it's worth, it's the column matrix 2, -2, 2. You should be able to see that. So now when we do this matrix product, here's how I actually go about it. So this guy is 3 by 3. This guy is 3 rows by 1 column. So the 3 and the 3 match. Our product matrix should then be 3 rows, 1 column. All right. So I'm going to have 1, 2, 3 rows. Each row just has a single value in it. In order to pin down that value, so remember, the way we label these, 1, 1, 2, 1, 3, 1, right? So you can use that indexing to tell you what you need to do in terms of the multiplication. So I want the first row of my left-hand matrix. That's that 1, 2, 1. And then I want the first column of the right-hand matrix. Yeah, we only have 1 column, but the process would work even if we had more. So now we basically sort of march to the right and down, multiplying together corresponding values. 1 times 2, 2 times -1, 1 times 2 again. Okay, so now, as written, you might look at this and say, well, Professor Carroll, that's three numbers. We should only have 1 value, right? That's where this comes in. Once we do the multiplications, we need to add these guys together. All right, so we're going to repeat that process for the next one down. Except this is 2, 1, so we want row 2 of our first matrix, still the first column, and we kind of keep going down the line. 3 times 2, 4 times -1, -2 times 2. All right. You do this one last time for the bottom entry. Again, that's row 3, column 1, row 3, column 1. We march down, doing multiplications and then add up the results. So we have 2 times 2 plus 0 times -1 plus -1 times 2. Now we crank out the arithmetic. 2 minus 2 plus another 2. We get a 2 in the first entry. 6 minus 4 minus another 4. That's a -2. 4 plus 0 minus another 2 gives us 2. And that is, in fact, the proposed right-hand side of this thing. So it turns out X, Y, and Z do in fact act as a solution to the matrix equation that's posed in, in example 2 right there. Now, at this point, you probably noticed there's a lot of little pieces into this, right? So, you remember before we did matrix addition, we basically had, the size, the dimensions times each other. So like if we were adding the other two 3x3 matrices, we'd have 9 different additions to do. This seems a good bit more complicated, right? So in order to work out these 3 values, I had to do 9 multiplications, and then, we got 6 plus signs in there hooking all this up. That is a lot of places to do arithmetic. It's not necessarily hard, but there's a lot of places to slip on, missing, grabbing the correct entry. There's a lot of places you can make a little mistake. So while you can do matrix multiplication by hand, I would generally recommend that you hand it off to some sort of technological tool. And that is what I'm going to show you how to do both with the calculator and with Microsoft Excel in our next video.